Hello, this is Shreyan Soni. I'm submitting my demo for CS7GV03 assignment 4 on MIP mapping in OpenGL. Today I'll demonstrate all 4 MIP mapping filter modes from my main.cpp program. Explain their technical differences, show when no MIP maps actually work better, cover LOD bias concept, and do live demonstration with texture switching, tile scaling, and object rotation. My scene features a rotating checkered tile floor model from Sketchfab with either a high frequency checkered pattern or smooth swirl texture. I use a GLFW for window management, MGUI for interactive UI sliders and drop-downs, GLM for matrix math, and standard GLSL shaders. All external libraries are properly referenced in my code comments as required. Let's start the program now so you can see the interface. You'll see the min filter drop down with 6 options. First 4 use MIP maps. Mag filter, LOD by slider, tiles from 0 to 10, rotation speed and camera controls with WASD plus mouse look. First, let's cover what MIP map solves. When texture gets minified, meaning many pixels map to few screen pixels, like when you zoom out or have dense styling, you get two problems: Moir pattern from aliasing and performance hits from oversampling the full resolution texture. MIP mapping fixes this by pre-computing a chain of progressively smaller texture versions, each half the resolution of the previous, down to 1 by 1. OpenGL calls these MIP levels. During rendering, the GPU automatically selects the best level based on the pixel to pixel ratio called LOD. My code calls texture.change MIP map, min filter, mag filter, and load bias to set these dynamically through MGUI. Now the main demo. I'll set the tiles to 5, medium density, where aliasing starts showing, and cycle through the 4 MIP map modes while rotating and zooming out slowly. Mode 0, GL linear MIP-map linear, also called trilinear filtering. This does linear interpolation of pixels within each MIP level, plus linear blending between the two closest MIP levels. Result: smoothest possible transitions, virtually no aliasing, but highest GPU cost. This is the gold standard for high-end games. Mode 1, GL nearest MIP-map linear. Nearest neighbor texel sampling within each level, but linear blending across levels. You get sharper individual texels with smoother level transitions, faster than trilinear but still high quality. Mode 2, GL linear MIP-map nearest. Linear texel interpolation but sticks to the single nearest MIP level. Great balance of quality and performance, no cross level cost. GL nearest, MIP map nearest. Nearest everything, single level, fastest MIP mapped option, but you can see shimmering on diagonal angles. Save this for performance critical cases. The key difference: texel interpolation controls sharpness versus blur within a level. MIP level selection controls how smoothly you transition between resolutions. Trilinear gives you maximum quality, nearest prioritizes speed. But maps aren't always the best. Let me set tiles to 0.5, very sparse. Large tiles, close camera. We compare mode 0 versus mode 4 and 5. Mode 4 linear and mode 5 nearest don't generate or use MIP maps at all. They always sample the base level. Notice how much crispier the tiles look? MIP mapping forces coarseness that creates artificial blurring on oversized texels. This looks wrong for close-up surfaces. Use no MIP maps for UI elements, hero assets viewed up close, billboards, or any use cases where we want maximum texture fidelity without the forced downsampling. LOD and bias. LOD stands for level of detail. It's calculated as log base 2 of your screen pixel coverage. LOD 0 is full resolution, LOD 1 is half resolution, LOD 2 is quarter resolution, and so on. The bias slider adds an offset. Negative values like 0, -1 force finer level of sharpness result. Positive values like +2 picks coerce level for extra anti-aliasing. See how negative bias fights distance blur while positive bias softens everything? This completes the CS7GV03 assignment. 4 requirements: GLSL mapping demonstration with all filter modes, rotating scene objects, and visual variety through tiling and dual textures. Source code with full references submitted separately. Thank you.